Hi, welcome to Igcse and A-level chemistry channel. Metals and non-metals. Metals and non-metals. Okay, there are many elements in the nature. There are different types of elements. These elements included in a table. This table called a periodic table. See here, this is periodic table. In this periodic table, you can see there are different types of elements. Okay, here metals, non-metals and metalloids. Okay, these are the major types of elements in the periodic table: metals, non-metals and metalloid. Okay, also here some example for metals. See here, iron, silver, gold, platinum. These are some example for metals. Also there is some example for non-metals: carbon, sulfur, iodine, bromine, oxygen, nitrogen. These are non-metals. Boron and silicon. These are example for metalloids. Boron, germanium, silicon. These are example for metalloid. Okay. Now see here, these are the major classification of elements. Elements we can classify: metals, metalloids and non-metals. Okay, example for metals: iron, silver, gold, platinum, copper. These are example for metals. Metalloids, example for metalloid: boron, silicon, germanium. These are example for metalloids. And example for non-metals: carbon, sulfur, iodine, bromine, oxygen, nitrogen, hydrogen. These are example for non-metals. Okay, so these are the major classification of elements. So see here, to classify metals, non-metals and metalloids, what basis we classifying elements? To classify elements, we will consider their physical properties and chemical properties. We will observe what type of properties these elements showing. Mainly we will consider their physical properties and chemical properties. Okay, so here elements showing two different type of properties. Which are the two different type of properties? Physical properties and chemical properties. Physical properties mean melting point, boiling point, conductivity, melting point, boiling point, conductivity, appearance of these metals, appearance of these elements, hardness of these elements. This type of properties are called physical properties. Physical properties mean what type of properties, such as melting point, boiling point, conductivity. Similarly, how they appear, appearance of the elements, hardness of the elements. Okay, is the metal is shiny or not shiny? This type of properties are called physical properties. Chemical properties, another one, chemical properties. Chemical properties mean how these elements react with water. You know, some elements it react with water. Example, sodium. When you put sodium or potassium, when you put these metals in water, it will react vigorously. It produce flame, it produce heat. Okay, so such type of metals like sodium, potassium, it react with water. But some metals like gold, silver, it do not react with water. So elements it react with water. Elements it react with acid. Okay, so such type of properties called chemical properties. How these elements reacting with water, how these elements react with oxygen, how these elements react with different type of acid. Such type of properties are called chemical properties. Okay, so here we discuss there are three different types of elements: metals, metalloids, non-metals. Example for metals: iron, silver, gold, platinum, copper. These are example for metals. Metalloids mean this type of elements showing both metallic and non-metallic properties. Metalloids mean elements they showing both metallic and non-metallic properties. Such type of elements are called metalloids. Example for metalloid, major example for metalloid: boron, silicon, germanium. Boron, silicon, germanium. These are example for metalloid. Okay, another classification: non-metals. Non-metals mean non-metals example: carbon, sulfur, iodine, bromine, oxygen, nitrogen, hydrogen. These are the example for non-metals. Also you understand most of the metals are hard. Most of the metals are hard. They have high melting and boiling point. They are in solid state. Most of the metals are solid state. You know, iron, silver, gold, platinum, they are solid state. Okay, and they are hard. Okay, so here they are solid state except mercury, Hg. Mercury, it is metal, it is liquid state at a room temperature. Mercury, it is liquid state at a room temperature. So this is one exception case. This is one exception case. Generally metals, they are solid state. Okay, these are example, and except mercury, it is liquid state. Mercury, also gallium. Mercury, gallium, these are solid state. Mercury, it is here remember mercury is example for metal, it is liquid state. Clear? Another one, metalloids, also these are solid state. Generally this example: boron, silicon, germanium, these are metalloids. These are solid state. Look here, here's some difference. Non-metals, it exists solid state, it exists liquid state, also in gaseous state. I told you these are examples for non-metals. Okay, this non-metal, it exists in solid state, liquid state, gaseous state. So example for non-metal which exists solid state: carbon, sulfur, iodine. Carbon, sulfur, iodine, they are non-metal, it exists in solid state. And another one, non-metal, it exists liquid state: bromine. Bromine, it is non-metal, it exists liquid state. And non-metal in gaseous state, example: oxygen, nitrogen, hydrogen. Oxygen, nitrogen, hydrogen, they are physical properties of metals. Physical properties of metals. See this diagram, see these pictures. So observe these pictures carefully, and these pictures showing different physical properties of metals. Okay, so there is gold, copper wire, okay, aluminium plate, aluminium pots are here. Okay, so here these are showing different metals and their different uses, different purpose. Okay, now come back here. Here, observing these pictures, here we can say some physical properties of metals. I told you in the beginning, physical properties mean, what does mean physical properties? Physical properties mean how metal observe, how it observe, how it appear. Is it hard or soft? Is it colorful or shiny? Okay, and how it's melting and boiling point. Okay, this type of properties are called physical properties. Okay, now see here, observing the pictures which I given above, you can say metals are shiny. Metals are shiny. Okay, and metals are shiny mean you can say metallic luster. Metallic luster. Metals are shiny. That's why we can say metallic luster. Metals, they have luster. Metallic luster means metals are shiny. Okay, generally metals are hard. There are soft metals also. Some metals in periodic table, I show you in the beginning periodic table. In the periodic table, in the beginning, first two groups, group 1 and group 2. Okay, these are called alkali metals and alkaline earth metals. Alkali metals and alkaline earth metals, they are soft metals. They are soft metals. Okay, rest of the metals are generally hard. Rest of the metals, like metals which coming in the middle of periodic table. Okay, you know, this is the shape of the periodic table which I shown in the beginning. This is the shape of periodic table. The metals which coming this part, it is group 1 metals. Metals which coming this part, it is group 2 metals. Group 1 metals and group 2 metals are soft. Okay, generally these elements, these metals are soft. Example, sodium, potassium, calcium, okay, magnesium. This type of metals are coming this part. Okay, and these metals are soft metals. But most of the metals are coming this part. Most of the metals are coming this part. Okay, these metals are called transition metals. Transition elements, okay, or you can say transition metals, because all of them are metals, transition elements. So these metals, they are hard, they have high melting and boiling point. Okay, here silver, gold, platinum, copper, this type of metals are coming this part. Okay, this example I given in the beginning. Now we discussed here, generally metals are shiny, metals are hard. You can say generally metals are hard, there are exception case, but generally you can say metals are hard. Okay, and next one, metals are malleable and ductile. Metals are malleable and ductile. Okay, see this diagram, see this picture. Here two pictures are given. There is copper wire and aluminium pots, aluminium sheet. Okay, aluminium sheet, thin sheet. So here this pictures showing we can convert metal into thin wire, metallic wire. Okay, properties of these metals are called ductile. Metals are ductile. Metals are ductile mean we can convert metals into thin wire, metal wire. That is called ductile. Metals are ductile. Gold is highly ductile. Which metal is most ductile? Which metal shows most ductile property? Gold. Gold showing most ductile property. Okay. And another one here, metals are malleable. Metals are malleable. Metals are malleable mean we can convert metal to metal sheet. We can change the shape of metal and we can produce different type of pots, different type of vessel. Okay, so you can say generally metals are malleable. Malleable mean we can change metallic sheet, metal sheet. Okay, that's why metal used to make cooking pot. Okay, metals such as aluminium and copper used to make cooking pot. Why aluminium and copper used to make cooking pot? Because aluminium and copper, they are malleable, also they are thermal conductor. Thermal conductor means they pass heat, they are good conductor of heat. Also aluminium and copper are malleable, that's why they use it to make cooking pot. Here we discussed metals are ductile, that's why metal used to make electric wire, electric cables. Why metal used to make electric cables? Because metals are good conductor of electricity, they are electrical conductor, also they are ductile. That's why metal used to make metallic wire. Which metal shows most ductile property? Gold showing most ductile property. Okay, here metals such as aluminium and copper used to make electric wire because they are ductile and good conductor of electricity. They are electrical conductor and they are ductile. That's why aluminium and copper used to make electric wire. Clear? So here metals are, I told you, metals are thermal conductor, they pass heat. Okay, so here you remember silver and copper. Silver and copper is best conductor of heat. Which two metals are best conductor of heat? Silver and copper is best conductor of heat. Silver and copper are best conductor of heat. Okay, and remember lead and mercury. Lead and mercury, they are metals and they are poor conductor of heat. So these are the examples. Thermal conductor, metals are thermal conductor. Silver and copper are best conductor of heat. Okay, mercury and lead, Pb mean lead. Lead and mercury, they are poor conductor of heat. Clear? Also here we discuss metals are electrical conductor. Aluminium and silver are best electrical conductor. Which two metals are best electrical conductor? Aluminium and silver. Aluminium and silver are best electrical conductors. Okay, and last point, metals produce sound. When you put metals in hard surface, when you put metal down in hard surface or you beat two metals together, okay, so they produce sound. When you put metal down, it produces sound. Okay, so you can say metals are sonorous, metals produce sound. Okay, so these are the physical properties. So I will repeat once again physical properties of metals. Here metals are shiny, means metallic luster. Metals are hard, generally metals are hard. Metals are malleable and ductile. Metals are malleable mean we can convert metals to metal sheet. Okay, example copper, silver and gold. Au mean gold. Gold and silver are example for, or silver and gold are best malleable metals. Okay, these two metals showing most malleable properties. And metals are ductile. Metals are ductile mean metals can convert into metal wire. Okay, gold showing most ductile property. Okay, metals are thermal conductor. Metals are thermal conductor. Here silver and copper. Silver, copper showing silver and copper are the best thermal conductor. Lead and mercury are poor thermal conductor. Okay, next one, metals are electrical conductor. Metals are electrical conductor. Aluminium and silver are best electrical conductor. Metals produce sound. Metals produce sound. That's mean metals are sonorous. Metals are sonorous mean metals produce sound. Clear? Non-metals. Example for non-metals given: carbon, sulfur, iodine, bromine, oxygen, hydrogen, nitrogen. These are example for non-metals. Okay. Here I given a table, different type of elements. Here in this table, not only non-metals, there is metals also. Metals and non-metals given. Also there are some different properties are given. Okay, these are elements, hardness of elements. Okay, is it these elements are shiny or not shiny? Is this metals or conduct electricity or not? Okay, so look here, first one, aluminium. Aluminium is hard. Okay, aluminium is hard. Aluminium is shiny and good conductor. Copper, hard, shiny, good conductor. Okay, mercury. Here you know aluminium is metal, copper is metal. Aluminium and copper, aluminium, copper, silver, they are metal. Okay, so aluminium and copper, they are hard. Okay, but mercury, it is liquid state. Mercury, it is liquid state. Okay, it is compressible, but they are not compressible. Okay, so you can say aluminium and copper, they are hard. Silver, mercury, it is soft. Okay, similarly here all these three are metals, but all these three not showing same properties. That's I want to show you here. All these three are metals, but they have different properties. This I want to show you here. Okay, these are metals, but they have different. Third one, soft. Also here all are correct, but here look here, third one. Here aluminium and copper is good conductor of electricity, but mercury is poor conductor of electricity. Mercury, poor conductor of electricity. Okay, so here even they are metals, but they showing different properties. Okay, and here see these three, bromine, iodine, carbon. Bromine, iodine, carbon. Okay, you know bromine, it is liquid state. In the beginning I told you bromine, it is liquid state, iodine solid state, carbon solid state. Even they are non-metals, but they have different physical properties. Look here two non-metals solid state, one non-metal liquid state. Okay, and see here their properties, shiny. This property here, iodine, it produce less stress. Iodine, it is less stress. Look here, iodine less stress means iodine produce shiny. Iodine is shiny. Okay, but rest of this bromine and carbon, they are not shiny. And look here, another one, these are non-metals, but here carbon is good conductor. You know carbon, it exists in two form, diamond and graphite. Carbon exists in two form, graphite and diamond. Here graphite, carbon in the form of graphite, it is good conductor of electricity. But here iodine and bromine, they are poor conductor of electricity. So this table showing you physical properties of elements not enough to classify elements. We did before, we classified elements, metals, non-metals, metalloid. Okay, first we learned their physical properties. We classify these elements based on physical properties. Okay, so here we are saying that according to this table, physical properties of the elements not enough to classify the elements. Why it is not enough? So you can say the answer, aluminium, copper, mercury, they are metal, but they showing different physical properties. For example, aluminium and copper, they are good conductor of electricity. Mercury, it is poor conductor of electricity. Okay, another example here, physical properties of the elements not enough to explain their classification. Not physical properties of elements not giving information to classify the elements. Why? Another reason here, bromine, iodine, carbon, they are non-metal, but they have different physical properties. For example, bromine, it exists liquid state. Iodine and carbon, they are solid state. And another one, all of them non-metal, but here carbon in the form of graphite, it is good conductor of electricity. Bromine and iodine, they are poor conductor of electricity. Clear? Look here some other information. You know, all metals are in solid state. All metals, also these are based on physical properties of the elements, not enough to classify the elements. Also we have to consider their chemical properties. That's I want to discuss with you. Physical properties of elements, not giving information to classify the elements. We have to consider their chemical properties also. Okay, so look here all metals are solid state except mercury. Another one, all metals have high melting and boiling point. All metals, they have high melting and boiling point except gallium. Gallium, it is metal, it will melt in our hand. When you heat the metals, gallium, in room temperature, it will melt. It change from solid state to liquid state. Clear? So all metals are solid state except mercury. All metals showing high melting and boiling point except gallium. Okay. And we are talking another, iodine, it is non-metal. We know non-metals, it do not produce shiny. It is not shiny. Okay, but iodine, it is lustrous. Iodine lustrous mean iodine it is shine. Iodine is shiny. Okay, and we know all non-metals are poor conductor of electricity, but carbon in the form of graphite, it is good conductor of electricity. Okay, also it is related to metals. All metals are hot. Generally all metals are hot except alkali metals. I told you in the periodic table, first group elements, it is alkali metals. Alkali metals like lithium, sodium, potassium, they are soft, they are not hot, even it is metal. Okay, so these are the things I want to discuss you in this part. Okay, rest of the part we will discuss next video.
Thank you for watching this channel. Please subscribe and press the bell icon for more videos. Thank you.